So let's do some reviewing of analysis of graphs. So in calculus, we learn a lot about graphs and their shape and the way they change and what they tell us about a function. So let's look through this activity together here. So we have a graph here. Now this is hugely important. This graph is the graph of the function f, or f of x. So that's important. You gotta know if this is the function itself, or this is a derivative, or what's going on here. All right. So let's find some intervals. We want to know where it's continuous. All right. Continuous means there's no breaks, right? And we can look at it, and pretty clear. It goes on forever. We've got our little arrows. So I think we could say that this is always continuous. All right. So this would be from negative infinity to infinity. Soft brackets, of course. All right, where is it differentiable? Well, where does differentiable, what does that mean? Well, that means that we can find the derivative, which means that it's not a sharp point. That's kind of what we're looking at there. So the slope coming from the left and the slope coming from the right need to the limit of that slope needs to be the same value. So there's no sharp points, there's no gaps, so it is differentiable everywhere, right? Okay, so it's differentiable on negative infinity to infinity. All real numbers. Okay, where is f prime? That's the derivative, remember. Where is the derivative less than 0? Well, the derivative is less than 0. That means it's decreasing, right? So let's make a note here. This is decreasing. Okay. So the slope, the derivative tells us the slope of the graph. And so where is that decreasing? Well, it looks like up to this point here. What is that point? Well, you can approximate that. It looks like, how about we call it, these should be symmetrical. My little lines don't necessarily look symmetrical, but let's call this negative 1.4. How about that? Okay, that's about 1.4 there, we'll say. Just estimating there, all right? So it's decreasing on negative infinity to that negative 1.4, right? So everything down to here. It's decreasing right here, right, from 0 to negative 1.4. Or actually, this would be positive 1.4, right? Positive 1.4. And that's it, right? All right, well, where is the derivative greater than 0? Well, that means it's increasing, right? So increasing means the slope is going up to the right. And so if this is our roller coaster, always thinking of it left to right, increasing from 1.4 negative to 0, that's this little section here, and from 1.4 to infinity, right? Okay. And last but not least, well, not last there, a couple more, but find the intervals where f prime is decreasing. Okay. So what does that mean? Well, that means the derivative of f prime is going to be negative. Okay, so if f prime is decreasing, that means the slope is getting less. So let's think about this. If we have a slope here, that's a very negative slope. And as we come down here, these little lines are getting less negative, right? So right here, okay, the slope is negative, but it's actually increasing. Okay, and it will continue to increase as we go around this corner, steeper, steeper, steeper. Well, where does that change? Do you remember? It's going to change right about here. Okay, and what's that point called? That's an inflection point, right? So we have an inflection point. I can't spell. point. All right, and so that's where it starts getting less. So here the slope is changing of these tangent lines and going to 0. Okay, so that is, and when that inflection point is there, okay, so we could say this. We could say the second derivative, the derivative of x is less than 0. And what does that tell us about the graph? That means it's concave down. Okay, so it's concave down. Where is it concave down? All right, we got to estimate these values a little bit here. Okay, so this is from, how about we call this negative 0.8? If you called it something different, that's fine. Okay, just kind of keeping this simple there. Okay, so 0.8. All right, so it's concave down roughly from negative 0.8 to 0.8. Okay, I'm just estimating there. All right, and the rest of it is concave up. So where is it increasing? Well, increasing means that the second derivative, the derivative of the derivative, is greater than 0. Okay, because that means f prime, the change in f prime, that would be the change in f prime, the second derivative, is greater than 0. All right, and so that would be everything up to that point there. So that would be negative infinity to negative 0.8 and 0.8 to infinity. Okay? All right. There you have it. Let's look at the next page. All right, that was pretty straightforward. Well, here we have a graph of f prime. So this is now f prime. Keep that in mind. That tells us something about the function f. So we want to know where f is increasing. So we got to ask ourselves this: when f is increasing, what's true about f prime? Well, this means f prime is greater than 0, because the derivative is the slope, which is the change in the graph, and so the slope is positive, greater than 0. That means it's increasing. Okay, so even before you look at the graph, don't go look at the graph, write that down. Real important, it's even on the AP test, real important that you write that down. So the slope is greater than 0, or the derivative graph is greater than 0. Well, where is the derivative graph greater than 0? Well, right here. There it is, 0, and so we've got to have a kind of a jump there. We've got to break it up right on that M, right? But we've got to break it into two parts. So we have a dial tone. We have from, again, what do we call that? That's, well, that looks like that's right at 2. 1, 2, 3, 4, 5. So that's right at positive 2, and that's at 2 there. Okay? So from negative 2 to 0, and from 0 to 2. Can we just call that from negative 2 to 2? Well, not really, because right at 0, it's not increasing or decreasing. The derivative is 0, right? And when the derivative is 0, well, we'll come back to that in a minute. Think about that. Hold that thought. All right, where is it decreasing? All right, well, let's go back to it. That means f prime of x is less than 0, and that would happen on the outsides. So out here, from negative infinity up to 2. Okay, so actually really over here, right, because this graph continues going, even though it's really steep, it continues going down to the right, yeah? Okay, so at some point, this graph, at negative 10, there will be a point way down there, right? But it's always going to be below. So it's going to be from negative infinity to negative 2, and then from 2 to infinity. So that's those outside little parts right there, okay? All right. So where does it have a relative maximums and minimums? Let's talk about those. All right, so at the maximum or the minimum, we have our derivative is equal to, what is it equal to? The derivative is equal to 0. And that's true for both of these, but we've got to look at the sign change. So the sign change, to do this, it's kind of nice to make a number line. So let's make a number line. And let's go, okay, number line. And we've got 0, we've got -1, -2, and 1, 2. All right. So there's a number line to match this. We're just looking at the sign. Okay. So this part of the graph that's to the left of -2, that is negative. So I'm going to put a negative up here. And then from -2 to 0, this part, the graph of f prime, we should write that here, that's f prime. The graph is positive. And then from 0 to 2, it's positive. And then from 2 to infinity, it's negative. All right? So we have 3 possible minimums and maximums here. But what has to happen? Okay, well, we have to have a sign change, right? So we're decreasing, then we're increasing. I'll write this here. So between 0 and 2, the graph of f will be increasing. And from 0 to 2, the graph is increasing. And from 2 to infinity, it's decreasing. Okay, so the actual graph of f is going to go down, up, and this is going to have that'll be an inflection point. Whoa, that's looking a little ugly. Down, up, inflection point, maximum, something like that. Okay, maximum at 2, minimum at -2. So how do we know that? We know that because the sign changes. Okay, so at -2, we have a minimum. So that's at x equals -2. And at x equals +2, we'll have a maximum. Got a max, min, minimum. And that means here we have an inflection point. All right? So at an inflection point, the derivative is equal to 0, and the sign doesn't change. So that's at x equals 0. All right, well, there you go. There's a quick review on some of the important things. It gets a little trickier when we have this graph of the derivative, but just take your time. Number lines are super helpful. Number lines are helpful because you can ignore the graph. You can draw that number line and then ignore the graph and just focus on this. That can help a lot, okay? So, all right, well, there you have it. Use those number lines and always remember to write down these things, translate these words into these expressions. That helps a lot. All right, thanks a lot.